We've made some really good progress on our Sudoku program so far, but wouldn't it be really frustrating if all of that progress was lost? Right now, that's exactly what happens when our user exits the program. Let's fix that in today's video by making our game save its progress so we can come back later without missing a beat. Hello everyone, my name is Mike and you're watching Polymath Unlimited. In this series, we are learning the C++ programming language by building our own Sudoku game. In the last video, we learned how to use ANSI escape codes to add color to our console programs. In this video, we will learn how to make our programs read and write files. This will let us add a save game feature to our Sudoku game, allowing the player to leave and come back later without losing their progress. In order to read and write files, we need to include the fstream library. This will allow us to use input file streams and output file streams, which let our program take input from a file or give output to a file, very similar to how IOStream lets us input from or output to the console. However, fstream takes a little bit more setup to use than IOStream. So we'll add two new functions to our program, load and save, which will handle both setting up the fstream objects and reading or writing data to or from a file. Both of these functions will return a Boolean value representing whether the load or save was successful. They will also accept a file name and a board state as parameters. Now let's flesh out these functions, starting with the save function. In order to save data to a file, we need to declare an ofstream object. Let's declare one at the beginning of the save function and call it fout. Just like declaring variables, you can name your ofstream object whatever you want. If you are writing to multiple files at the same time, declaring multiple ofstream objects with different names allows you to keep track of what data is being written to which file. However, for simple things like we are doing in this program, I usually like to just name my ofstream objects fout, because they behave just like cout would if we were using IOStream to write to the console. Now that we have an ofstream object, we need to open a file. We can do this by using the open method of the ofstream class and passing the file name to it. We'll learn more about methods when we start talking about object-oriented programming, but for now, just think of it like a special function that tells our ofstream object to do some task, in this case, opening a file. Now that we have an ofstream object and an open file, it's a good idea to check for errors. We can do this by checking to see if fout.fail returns true. If it does, then something has gone wrong and the file was not opened properly. In this case, we should close the file by calling the close method of the ofstream class, and then letting our program know that something went wrong by returning false. If fout.fail returned false, then we are good to go, and we can start writing data to the file. We will use some nested for loops to write the board state to the file, just like we would if we were writing it to the console, just using fout instead of cout. Next, we need to make sure we close the file and return true, since the file was written successfully. For now, let's just have our load function do nothing and return true. We'll come back to this in a moment after we've made sure our save function is working. To verify that our save function is working properly, let's add an autosave feature to our Sudoku game that saves the board to a default save file when the user exits the program. In the portion of our game loop that runs the exit command, we'll add a function call to our save function, saving the board state to a file called autosave.txt. Now, if we run our program, type exit into the console, and check our file directory after the program exits, we should see a file called autosave.txt that contains the board state that we had when we exited the game. Now that we can save games to a file, let's turn our attention to the load function. Here, we need to declare an ifstream object. Similar to the ofstream object we have in our save function, I usually like to call my fstream objects fin, because they work just like cin from the iostream library. Once we have declared our ifstream object, we'll open a file and check for errors, just like we did with the save function. Then, we'll use some nested for loops to read from the file into the board array, making sure to read the numbers in the same order that we wrote them in our save function. We can then close the file and return true. Now, you might have noticed something strange about our load function. The load function returns a Boolean value, but it doesn't return a board array. So, how exactly do we get the data from the board array that our load function is using into the board array that our game loop is using? The answer is actually deceptively simple. You see, normally when we pass arguments to a function, the argument's values are copied into the variables used by the function. This means that if we modify the value of a variable from within a function, this change is not reflected in the variables we passed into the function. However, the board state we pass into our load function is not just a simple variable. It's an array. This means that we aren't passing the value of a variable into our function. Instead, we are giving our function a location in our computer's memory. So the board array we give our function and the board array that our function modifies internally both live at the same place in memory. So when our load function modifies its board, those changes are reflected into the board memory we passed into the function. It turns out that there are a lot of very useful things we can do when we work with memory locations instead of variable values. In fact, C++ has a very special type of variable called pointers that are specifically designed for these types of tasks. We'll wait for a future video to dive more deeply into pointers, but for now you should simply be aware that they exist, since there are a lot of very useful things we can do with them. Now that we have our load function completed, let's make sure it works by loading from the autosave file when the program starts. Before the game loop begins, we'll call our load function and load the autosave file into the board. Now, if we run our program, make some changes to our board, and then exit, we should see those changes preserved when we start the game again. This means we can leave the game and come back later without losing our progress. In the next video, we'll take the concepts we've learned here even further by implementing a simple file directory. This will allow the user to select from a list of saved games, making it so that we aren't limited to just the default save file. Until then, feel free to play around with what we have here and see what features you might want to add to your own version of this program. If you can think of any features that you would like me to add to the program in this series, let me know in the comments. Thank you for watching, and I will see you next time.